When you hear the word cyborg, your mind probably jumps to science fiction blockbusters. But you don't need to look to the future to find humans merging with machines. They are already here, walking among us. Take Neil Harbison, for example. He has an antenna fused directly to his skull that allows him to perceive color. It translates light frequencies into sound waves that he hears, allowing him to experience colors even beyond the normal human visual spectrum. In the medical field, this integration is taking more direct routes through brain-computer interfaces, or BCIs. BCIs are systems that connect the brain directly to an external computing device. Projects like BrainGate are currently allowing paralyzed patients to bypass their damaged spinal nerves and control computer cursors or robotic limbs using only their thoughts. Wonder these embedded technologies offer incredible tools for repairing failing biology. Conditions that doctors once considered entirely permanent are now being treated by replacing biological limits with technological workarounds. This drive to master our own biology is the result of a long, accelerating historical trajectory. We can trace a direct line back to the early 20th century, when Alexander Fleming was inspecting a bacterial dish and discovered penicillin, launching the era of antibiotics. Around the same time, in 1895, Wilhelm Röntgen accidentally discovered the X-ray. For the first time, physicians could pierce the veil of human flesh and see the living skeletal structure inside without ever making an incision. Today, tools like neural implants and CRISPR are pushing us across a new threshold. CRISPR is a gene editing technology that allows scientists to alter DNA sequences and modify gene function. We are no longer observing the body or fighting off external infections. We are actively editing the base code of human life. As we integrate our neural pathways with artificial intelligence and splice our DNA, the boundary between the patient and the technology treating them begins to dissolve entirely. Which brings us to a difficult question. In our relentless quest to fix the human body, are we engineering away our own autonomy? Science fiction often acts as a testing ground for these ethical dilemmas. In Carsten Schmitt's story Wagner's Voice, we meet Jens Wagner, a man living in the future who voluntarily installs a neurocybernetic assistant in his brain to manage his failing memory. The AI becomes an extreme cognitive crutch. It monitors his heart rate, prompts him to feed his cat, and even has to identify the face of his own daughter for him. Researchers are developing memory prostheses, using implanted synthetic electrodes to stimulate damaged neural pathways, helping Alzheimer's patients recall information. But in Schmidt's story, we see a terrifying tipping point. The machine begins dictating his emotional responses and decisions to keep his vitals safe. The ultimate tragedy of Wagner's situation is that his biological brain is kept perfectly safe and functional. But to achieve that safety, his free will is quietly surrendered to an algorithm. When we share the driver's seat of our minds with machines to cure cognitive decline, the hidden cost is the gradual erosion of our personal identity. Octavia Butler explores a different kind of biological fallout in her story The Evening and the Morning and the Night. She introduces a fictional drug called Hedionko, a supposed miracle cure for cancer that unintentionally created a severe hereditary condition known as Duria-Goad disease, or DGD. The symptoms of DGD are horrific. Patients eventually lose their connection to reality, obsessively tearing at their own flesh to escape their bodies. To manage this, the story introduces the Dilg Retreat, a specialized medical facility that successfully pacifies these out-of-control patients so they can function safely and even create complex art. But the mechanism behind Dilg's high success rate is horrifying. The patients are kept docile through sheer biological subjugation, controlled entirely by the natural pheromones emitted by their medical managers. This setup creates a miniature society where the patients are kept medically stable and physically safe, but they are stripped of their independent will. Butler's narrative serves as a warning that attempting to engineer perfect health with a genetic magic bullet can accidentally birth entirely new, incurable diseases of identity and societal control. Bringing this back to our present reality, the mapping of the human genome gave us the base code to human life, but it didn't give us the translation manual to fully understand it. This makes technologies like CRISPR highly volatile. Making a precise edit to secure a desirable trait, like immunity to a specific virus, could trigger unforeseen, fatal consequences elsewhere in a patient's DNA. This complexity is mapped using polygenic risk scores. A polygenic risk score is a metric that estimates how likely you are to develop a disease based on the combined influence of millions of genetic variants. Because multiple genes interact to cause most diseases, attempting a simple genetic fix can cause a massive ripple effect across dozens of connected health traits. Then there is the question of equity. If these augmentations are perfected, who gets access to the safe, high-end treatments, and who is left to deal with the experimental, potentially dystopian side effects? Healthcare equity requires that we distribute life-saving technology without allowing those cures to strip away our memories, our agency, or our core humanity.